All right. Welcome to this lesson on arrangements, or otherwise known as permutations, which are separate from something else we do next lesson called combinations. All right, so permutations are just arrangements. So examples are, how many ways are there of arranging 4 different books on a shelf? And the best way to think about it is that you have 4 slots, which are the 4 positions on the shelf, and we have a different number of options for each slot. So I have 4 options for book 1. If I use that book 1 in slot 1, I have 3 options in slot 2, 2 options in slot 1, and the last option is set. Now, we learnt last lesson that to do this, which is where we can look at different steps of an experiment, we just multiply these together, which tells us the total number of ways of arranging. So 4 times 3 times 2 is 24, times 1 is 24. Now, this means that there are 24 different ways of arranging 4 books on a shelf. Okay? Now, this can also be written as factorial. And factorial just means everything underneath that number down to 1 multiplied together. It's important to note we do not multiply 0 in there, because that would mean that everything just ends in 0. All right, so we don't do that. Factorial is just everything down to 1. And if you want to know what it looks like algebraic, it looks like this. So it's n times n minus 1 times n minus 2 times n minus 3 times all the way down to 1 at the bottom. All right, so this is what it is algebraically, and it's called factorial. And we use it to look at arrangements. All right, so another example question looks like this. A group of 12 students is to have a photo taken. How many ways are there of arranging the group if they sit in a row? And that's important that they're sitting in a row, because other arrangements are difficult to work with. So again, we have 12 slots. 5, 6, 7, 8, 9, 10, 11, 12. I have a choice of 12 students for the first one, 11 students for the second one, 10 students, and so on down to 1. So I can write it as 12 factorial. 12 factorial is able to be done on your calculator. I'm not going to write it out. It is 479,600 different ways of arranging 12 students in a row, which is rather large. All right, now factorials are a good way of getting big numbers very quickly. As you can see, 12 factorial is this big, and no one wants to try out this many different arrangements to work out the optimum one. All right, so keep that in mind. What about something like when we don't have that many options, like this? A painter is to paint the 5 circles of the Olympic flag, so only 5. He cannot remember the colours to use, but he knows they should all be different, so 5 different colours. He has 8 to choose from. How many ways can he paint the circles on the flag? So I have 5 slots open for the 5 circles. All right, but this time, how many choices do I have for the first one? So I have 8 choices. Once I've used that color, because they're all different, I have 7 choices, then 6, then 5, then 4. So we can see that it's not quite all the factorial, it's just 8 down to 4. Now 8 down to 4 equals 6,720. But again, that's not a number that I'm willing, as a painter, I'd want to try out 6,720 different attempts. So I'd want some extra information. All right, these are all hypotheticals. Now that leads us to looking at the fact that we can't just use factorial for this one, because it's not all of it. So there's a little formula we can use to work out arrangements, given that we don't use all of the options available by the end. And the formula looks like this. Okay, so n is the number of total options available. So in this case, it would have been 8 factorial. R is the number of spaces you have. Okay, so I'll annotate that for you. Options spaces. Okay, so in the denominator, we have the full number of paint, which is 8 factorial. In the numerator, I have 8 minus 5 factorial. Now I want to work out what that is. This is 8 factorial over 3 factorial. Now, I'm not going to calculate it, I'm just going to expand it for you so you can see what happens. Alright, so you can see here, that's 8 factorial. This is 3 factorial. And what's going to happen is that that is the same as that, and they're going to cancel out, and what I'm left with is what I wrote up here. So this formula will work for everything. All right, we divide it by the leftovers, if you will, to remove them from the numerator so that we can use this factorial notation all the time. We just can't use it like we did up here in the first couple of examples, because in the first couple of examples we were looking at using all of the options available, whereas in the next example we're looking at using only some of the options available. All right, so this idea is called permutations, where we can use some of the options available out of a given set. So have a look at another example here. Find the number of 4-digit numbers that can be formed from these digits here if each digit can only be used once. So I have 4 digits to make a number. I can use, say, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 available slots there, which means I have 8 there, 7 there, and 6 there. Okay, so I can multiply those together, and I can work out that that is 3024. Or, if I wasn't quite keen on doing that, I could use the formula. I could go 9 factorial over 9 minus 4 factorial, which will be 9 factorial over 5 factorial, which will get me the same answer. So that's a way of doing it on our calculators. All right, and I'll show you how to get that up at the end of the lesson. So this is the answer. There are 3,024 different ways for A. If they can be used more than once, I have 9 numbers in the first slot, 9 numbers in the second slot, 9 numbers and 9 numbers, which is really simply just 9 to the power of 4, which is 6,561. All right, so this is basically with replacement, and this is without replacement. Once we've used a number, it's not able to be used again. Okay, so the formula is a nice way of jumping straight to the answer in case we didn't want to go through the process. And for small numbers, it's not so bad, but for other numbers, it can be quite painful. So the last one we'll look at is this one here, which has a little bit more complexity in it. How many different even 4-digit numbers can be formed from 1 through 8 if each digit may only be used once? So we have 4 slots. All right, but this one has a requirement of being even. So the end digit has to be a 2, a 4, a 6, or an 8. So I've only got 4 spots or 4 numbers that can fit there. So this is called a restriction, and it restricts the choices available for the other 3. So if I've used 4 of them here, or 1 of them here, that means I have 7 available for the first slot. If I've used 1 there, I have 6 in the third and 5 in the, 6 in the second and 5 in the third. And I multiply those together and I will get my answer of 840. All right, so there's a restriction involved which needs to be carefully looked at. Okay, so to finish off, this idea is called, permutations, which are just arrangements of objects. And there is a formula we use for it, which is n factorial over n minus r factorial. Or you can just list the slots and carefully read each question.